Very good afternoon, children. Let's move on to few more sums from the first exercise, and then we'll learn how to represent a complex number on Cartesian plane and what do you mean by modulus and argument. So the first question is, if a plus 3i upon 2 plus ib is equal to 1 minus I, you have to show that 5a minus 7b 0. So remember, when we are dealing with complex numbers with the help of an expressions, try to convert everything in the form of complex number on left side as well as right side. तो मैं क्या करता हूँ, I'll write this as a plus 3i and I'll cross multiply. So 2 plus ib into 1 minus I, that is a plus 3i. क्या हो जाएगा? I'll multiply the brackets. So 2 minus 2i plus ib minus I square b. करेक्ट? अब मुझे मालूम है I square कितना होता है? -1. कितना होता है I square? -1. So this -1 and minus becomes plus. So 2, I'll take I common from here. If I take I common, ये आएगा b minus 2 and this will become b. That is, left side में there is a complex number a plus 3i. Right side maybe there is a complex number like this. Now since two complex numbers are equal, I can say that real part on left side is equal to real part on right side. Imaginary part on left side is equal to imaginary part on right side. From second part मुझे b कितना मिलेगा? I'll get b as 5. Correct? And what is the value of a, children? A क्या है? 2 plus b. b कितना है? 5. Therefore I am getting a as 7. a कितना मिला? 7. Now take LHS. What is LHS? 5a minus 7b. So 5 into 7 minus 7 into 5. So 35 minus 35 कितना आएगा? 0, which is equal to RHS. So what I did, I just took the complex number of denominator on right side. I simplified. Then as usual, real part is equal to real part, imaginary part is equal to imaginary part. ठीक है? Next, if a is equal to minus 1 plus root 3 I by 2 and b is equal to minus 1 minus root 3 I by 2, you have to show that a square is equal to b. Now since I want to show that a square is b, I will first find what is a square. तो a square कितना आएगा? Minus 1 plus root 3i by 2 the whole square. Correct? So denominator becomes 4 और minus 1 plus root 3i का square मतलब a square plus 2ab plus b square. Am I right? I'll just simplify this part. ये हो जाएगा 1. Middle term will become minus 2 root 3i. Now we know that I square is minus 1. Root 3 का square is 3. तो ये आएगा minus 3. Correct? Upon 4. Now I'll take the like terms together. So 1 minus 3 minus 2 minus 2 root 3i upon 4. I will take 2 common. So what is left? Minus 1 minus root 3i by 4. Correct? So 2 2s are, that is minus 1 minus root 3i by 2. If you observe, this value and value of b both are same. Therefore I can say that a square equal to b. What can I say? A square equal to b. Similarly, you can try as a homework. You will get that b square is nothing but a. Similarly, you will try this. You will get b square is equal to a. Understood? Next, show that this particular expression is real. So हम क्या करेंगे? Simply I'll cross multiply. So it becomes root 7 plus I root 3 into root 7 plus I root 3 plus root 7 minus I root 3 root 7 minus I root 3. अब डिनोमिनेटर क्या हो जाएगा? a minus b into a plus b. Correct? That is a square minus b square. Correct? Now observe करो numerator. Numerator is a plus b the whole square. एंड सेकेंड पार्ट है a माइनस बी द होल स्क्वायर, करेक्ट. सो हो जाएगा 7 प्लस 2√3√7i प्लस √3i द होल स्क्वायर. सिमिलरली 7 माइनस 2√3√7i प्लस √3i द होल स्क्वायर. अब डिनोमिनेटर क्या हो जाएगा, दिस विल बिकम 7, √3 का स्क्वायर इज 3, so it becomes plus 3. So 2√3 कैंसल, 7 प्लस 7 कितना आएगा बच्चों, 14. √3i स्क्वायर मतलब -3, √3i स्क्वायर मतलब -3, -3 -3 -6/10. It is coming out to be 8/10 which belongs to real. Therefore given expression is real. You can say 4/5 also. 4/5 आंसर आ रहा है which is a real number. So I can say that given expression is a real number. Very simple sum. सिर्फ क्रॉस मल्टीप्लाई करना है और बेसिक ऑपरेशंस अप्लाई करने हैं. You will get the answer. Understood? Now let us understand how to represent complex number on our Cartesian plane, that is on our graph paper. So we know that my z, a complex number, can be written as a plus ib. So for example let us say I take z as 2 plus 3i. मैं क्या ले रहा हूँ z को, 2 plus 3i. So the mathematicians said that we can assume the x-axis as a real part of complex number and y-axis as imaginary part of complex number. मतलब ये 2 हो जाएगा मेरा x कोऑर्डिनेट, ये 3 बन जाएगा मेरा y कोऑर्डिनेट. So if I want to represent complex number on Cartesian plane, my 2 plus 3i, suppose ये 2 है and this is 3. So 2 plus 3i will come here. This will be my complex number 2 plus 3i. Let us say O, let us say Z. So this OZ distance of this point from origin, that is OZ. This OZ represents modulus of complex number. OZ represents modulus of complex number. The distance from origin to that point of complex number is called as modulus. It is noted like this, mod Z. It is noted like this, mod Z. Now that OZ is making an angle theta with positive direction of x-axis. If you see, OZ makes an angle theta with positive direction of x-axis. That theta is nothing but argument. Remember, angle made with positive x-axis only. That theta is called as argument or it is called as amplitude. That theta is called as argument or it is called as amplitude. And the representation of complex number on this plane is called as Argand diagram. This is called as Argand diagram. If we locate the coordinates, we join with the origin and we show theta and modulus z, it is called as Argand diagram. So let us understand how to find the modulus. तो देखो, suppose I'll draw this as triangle now. ये O है, ये A है, ये Z है. Now my z is suppose x plus iy and my angle is theta. ठीक है. So मेरा OA कितना आएगा, x. AZ कितना आएगा, y. So if I apply Pythagoras theorem, my mod z, that is OZ, कितना आएगा, square root of x square plus y square. Correct. If z is x plus iy, तो इस complex number का modulus आएगा mod z is equal to square root of x square plus y square. In short, I can write mod z as square root of real part of z का square plus imaginary part of z का square. Remember, इस mod z में I कभी नहीं आएगा. Real part मतलब A, imaginary part मतलब B. I am not saying IB, I am just saying B. Okay. Now I want to find theta. Now tell me from the figure, what will be tan theta, children? Tan theta आएगा y by x. क्या आएगा tan theta? Y by x. But I am interested in theta, so I'll get theta as tan inverse y by x. when the function goes on right side, it becomes inverse. This will learn in detail in 12th standard. So my argument or amplitude theta is given by tan inverse y by x. क्या हो जाएगा theta? Tan inverse y by x, and modulus z will be square root of x square plus y square. Modulus z will be square root of x square plus y square. Understood? Now let us try to represent this complex number in second quadrant and let us find what is theta. Okay? तो ना assume करो the complex number is in second quadrant. अगर ये second quadrant में है तो मेरा थीटा कितना आएगा बच्चों? मेरा थीटा ये आना चाहिए, करेक्ट? This should my theta. So to adjust this theta, I'll say that my mod z will be same. अगर z मेरा complex number है x plus iy lying in second quadrant, though I have written xy positive, मैंने values नहीं लिखी है. So if z lies in second quadrant, कब lie करेगा? जब x negative आएगा, y positive आएगा. तो modulus will remain same, that is square root of x square plus y square, and my theta will be pi minus tan inverse mod of b by a. क्या आएगा? Pi minus tan inverse modulus of b by a. Why I am subtracting by pi? Because I want this obtuse angle, but when I draw trigonometry, I will get this angle. So पूरे 180 में से ये अल्फा माइनस किया, I will get theta, because alpha plus theta is 180 over here. Theta plus alpha कितना है? 180. Therefore theta कितना आएगा? Pi minus alpha. Understood? Yes. Similarly, if z equal to x plus iy lies in third quadrant, कहाँ lie कर रहा है वो? Third quadrant. It will somewhere here. Then we always measure angle with positive x-axis. So this will be my angle theta. Correct? So here mod z remains same, no doubt. Square root of x square plus y square. My theta will be pi plus tan inverse mod of b by a. Pi plus tan inverse mod of b by a. Now similarly, if z lies in fourth quadrant, again mod z will remain same, that is x square plus y square, and theta will be 2 pi minus tan inverse modulus of b by a. 2 pi minus tan inverse modulus of b by a. फर्स्ट क्वाड्रेंट है डायरेक्टली tan इनवर्स, सेकेंड क्वाड्रेंट है पाई माइनस, थर्ड क्वाड्रेंट है पाई प्लस, फोर्थ क्वाड्रेंट है 2 पाई माइनस. बाय चेकिंग द साइंस ऑफ x and y, you can determine in which quadrant that complex number lies. Okay, let us solve certain sums based on modulus and argument of complex number. So to make it easy, I'll first write x. बेटा x कितना है यहाँ पर? 7. y कितना है? -5. x है 7, y है -5. x पॉजिटिव है, y नेगेटिव है. It means this complex number is lying in fourth quadrant. कौन से quadrant में lie कर रहा है ये? Fourth quadrant में. ठीक है. सेकेंड देखते हैं. My x is √3, y is √2. दोनों पॉजिटिव है. So it is lying in first quadrant. कहाँ lie कर रहा है? First quadrant. Here third one, x is -8, y is 15. x negative, y positive. Which quadrant? Second quadrant. Which quadrant? Second quadrant. Last, x negative है, y भी negative है. Which quadrant? Third quadrant. Correct? So let us solve. सबका मॉडुलस निकालते पहले, बिकॉज इट इज वेरी इजी. सो आएगा 7 स्क्वायर प्लस -5 का स्क्वायर. यह आएगा मॉड z इक्वल टू स्क्वायर रूट ऑफ √3 का स्क्वायर प्लस √2 का स्क्वायर. दिस विल बिकम मॉड z इज इक्वल टू -8 का स्क्वायर प्लस 15 का स्क्वायर. नाउ हियर मॉड z आएगा स्क्वायर रूट ऑफ -4 का स्क्वायर -4 का स्क्वायर. These values will write. Okay. Now first one 7 - 5 आए, कहाँ lie कर रहा है? फोर्थ क्वाड्रेंट. फोर्थ क्वाड्रेंट में lie कर रहा है. तो मेरा थीटा कितना आएगा बच्चों? माई थीटा विल बी हाउ मच? थीटा विल बी पाई माइनस, रिमेंबर सेकेंड क्वाड्रेंट है, थीटा आएगा पाई माइनस tan इनवर्स मॉड्यूलस ऑफ v बाय a, that is minus 5/7 का मॉड्यूलस, that is my theta comes out to be pi minus tan inverse 5/7. क्या आएगा थीटा? pi minus tan inverse 5/7. Understood? Now second one, it is lying in first quadrant, so directly answer आएगा theta is tan inverse b by a. क्या आएगा थीटा? tan inverse b by a. Okay, sorry children, the first one is lying in fourth quadrant, तो ये 2 pi minus आएगा. क्या आएगा? 2 pi minus. Okay, extremely sorry. The third one, it is lying in second quadrant, so क्या आएगा? Theta is equal to pi minus tan inverse modulus of y by x. Therefore मेरा theta आ जाएगा pi minus tan inverse 15/8. Okay, understood? Last one is lying in third quadrant, तो मेरा थीटा कितना आएगा? थीटा विल बी पाई प्लस tan इनवर्स मॉड्यूलस ऑफ x बाय y, है ना? दैट इज माय थीटा विल बी पाई प्लस tan इनवर्स 1, पाई प्लस tan इनवर्स 1. अंडरस्टूड? हाउ टू फाइंड मॉडुलस आर्ग्यूमेंट? इस मॉडुलस आर्ग्यूमेंट का फिर से रिवीजन होगा, because we need to use this modulus argument to solve our further sum. Understood? How to find modulus and argument of a given complex number? Yes. Next, a favorite question of the examiner. This sum has been asked in JEE Mains many times, just by changing the question that either the number is real or the number is imaginary. So I have told you, if the number is real, it means that imaginary part of that complex number is 0. कोई भी complex number अगर real होता है तो उसका imaginary part 0 आता है, और कोई भी complex number अगर imaginary है तो उसका real part 0 आता है. क्या 0 आता है? Real part. Correct? So first I'll convert this number in a proper complex number form, है ना? How will I convert? There is denominator. तो फर्स्ट आई नीड टू रैशनलाइज द डिनोमिनेटर. तो 1 plus 2y sin थीटा, 1 plus 2y sin थीटा. करेक्ट? न्यूमरेटर तो मल्टीप्लाई होगा, सो 4 plus 8i sin थीटा plus 3i sin थीटा plus 6i square sin square थीटा बराबर नॉर्मल मल्टीप्लीकेशन. डिनोमिनेटर हो जाएगा 1 माइनस 4i स्क्वायर साइन स्क्वायर थीटा. ठीक है? उसी ये i स्क्वायर हो जाएगा माइनस वन इंटू 6 माइनस 6, सो 4 माइनस 6 साइन स्क्वायर थीटा एक पार्ट हो गया. देन 8i प्लस 3i, दे आर लाइक टर्म्स, सो ये हो जाएगा 11i साइन थीटा. क्या हो जाएगा? 11i साइन थीटा. डिनोमिनेटर हम दोनों को देंगे so that it becomes a proper complex number. तो हो जाएगा 1 plus 4 sin square theta, 1 plus 4 sin square theta. ये होगा complex number के फॉर्म में. Now I want this complex number to be real. Since it is real, ये नंबर प्योरली रियल है, therefore इसका imaginary part क्या आना चाहिए? 0. अगर कॉम्प्लेक्स नंबर रियल है तो इट्स इमेजिनरी पार्ट शुड कम आउट टू बी 0. सो व्हाट इज द इमेजिनरी पार्ट इन दिस कॉम्प्लेक्स नंबर? इट इज 11 sin थीटा अपॉन 1 plus 4 sin square theta equal to 0. दिस विल बी पॉजिटिव नो मैटर व्हाट इज थीटा. सो हो जाएगा 11 sin थीटा इक्वल टू 0. देयरफॉर sin थीटा इक्वल टू 0. अब sin थीटा 0 किसके किसके लिए होता है? It becomes 0 for 0, it becomes 0 for pi, 2 pi, 3 pi and so on up to n pi. Sin theta is 0 for all multiples of pi. Sin theta is 0 for all multiples of pi. आया समझ में? Any doubts to anybody? Clear? It was very nice sum, है ना? and it has been asked many times in JEE mains.